guys, this is George, and this is our second video related to value at risk, and today I will show you how to calculate it with a parametric model in Python. We will continue developing the notebook from the point that we stopped in our previous video, so in case you miss it, there are links for the video and the code in the description. I recall to you that for the experiments we use historical data of Apple, Google, Facebook, Nvidia and Tesla 2016 until the end of 2021. In the previous video, we saw the historical VaR, and today we will implement the Variance-Covariance VaR, which is the main representative of parametric VaR models. In parametric models, we should make assumptions regarding the distribution of returns prior to the VaR estimation. This method calculates the standard deviation of price movements of an investment or security, and assuming that stock price returns and volatility follow a normal distribution, value at risk calculates the maximum loss within the specified confidence level. Therefore, in Variance-Covariance VaR, we should calculate the standard deviation of the data and the quantile of the normal distribution that corresponds to the given confidence level of value at risk. So let's implement a Python function that calculates Variance-Covariance VaR. For this, I will use the HS function that we have written in the previous video, and I will transform it in order to calculate Variance-Covariance VaR. So let's rename it to VC. The inputs of this function will be the same: the returns of the assets, the probability of VaR, and the time horizon of our prediction. So the first thing that I have to do is to make sure that the input returns are a NumPy array, which is important in order to make the multiplications between arrays and vectors. So for this I will use the NumPy array function, which I pass it through the input returns, and in the case that the input returns is an object that can be transformed to a NumPy array, this will work. In other case it will raise an error. Next, we need to calculate the standard deviation of the returns. NumPy has a built-in function for this, the STD, and we need to define the axis parameter and set it to 0, which means that it will calculate the standard deviation per column of the returns data frame, in which every column corresponds to a given stock. Besides that, we need to calculate the quantile of the normal distribution based on the given confidence level. For this, I will use the SciPy library, and from SciPy stats we will import the norm class, which implements several functions over the normal distribution. So for the norm class I will use the ppf function, which returns the percentile of the normal distribution of the given quantile. We also need to transform this to the exact quantile. For instance, if the input is of the confidence probability is 95, we need the fifth quantile. So 100 minus 95 equals to 5 divided by 100 returns the needed value for this. And also I should add here the standard deviation in order to be in line with the formula. I recall to you that we multiply this result with the square root of the time horizon in order to interpolate our daily VaR to different and higher granularities. And this is our Variance-Covariance function, and we can use the same example that we used in historical method to see how it works. So we have an investment of 1,000 euros in each stock. We set the probability confidence level to 95%, and now we will call the VC function instead of the HS. We call it with different time horizons, and we put the result in a data frame. And here we have the Variance-Covariance VaR of each stock. Now we will calculate also the portfolio VaR with the Variance-Covariance model. So to do that, we will extend the portfolio VaR function that we see in the previous video to support different Valuatrix methods. So all the current inputs, the returns, the weights of the portfolio, the confidence level of the VaR and the time frame will remain the same, but I will also add an extra parameter. Let's call it method, with default value being the HS for the historical method. I have also added here the description of this parameter, which is a string. As I said, the default says HS for the historical method, and it also can take the VC parameter for the Variance-Covariance. The only difference that we need to do here is to add an if-else statement in order to check the method input. So if method equals to VC, calculate the weighted VaRs using the VC function, else calculate it with a historical simulation model. The rest of the code remain as it is, and I will repeat the example that we used for the historical method in order to calculate the portfolio VaR of a balanced portfolio in which we split it 1,000 euros in the 5 stocks, which means 200 euros in each stock. The probability of the prediction is again 95. The only change that I have to do is to add the method to the portfolio VaR function and set it to VC. We calculate the daily VaR, monthly VaR, quarterly and annual VaR. And here are the results. If we compare them with a historical simulation model, we can see that Variance-Covariance VaR is a little bit stricter. It reports a higher VaR than the historical method. And of course, you can experiment yourself with different stocks and probabilities and portfolio weights. So thank you very much for watching. I hope you like the video, and see you in the next to calculate value at risk with a Monte Carlo model.